So anyway, this is Unlocking PyTorch with Prompt Engineering Part 3, and we'll be looking at ResNet, transformers, GANs, and deployment. Everything in this has been written through prompt engineering. Nothing was hand-coded. So it's pretty exciting for me to actually have gone through this whole series. A little bit about myself, and I am an avid generative AI hacker. I typically or participate in the AI hackathon every week. So I'm a nut about generative AI. Here's a bunch of links. If you want to get a hold of me, you can join my LinkedIn. And everything I do typically is free. So I also have a cloud meetup, Hugging Face, and a lab AI. In my Hugging Face, you'll probably find about 100 programs written in Python that you can actually access and play around with. So I'll go ahead and put that in the chat. Just a few events real quick here. We have, of course, we're learning PyTorch using Prompt Engineering Part 3. We're wrapping that up. So what I'm going to do on my LinkedIn is I'm going to actually post all this, and also on the cloud, all 3 sets of slides, all 3 videos. All right, let's just start off with a quick icebreaker. I always do icebreakers when I do these meetups. And so what unique quality do you believe AI will never fully replicate, and why? Intuition and gut feeling, humor and wit, cultural and historical understanding, philosophical and existential thinking, artistic expression and aesthetic appreciation, or spirituality and faith? Which one? 1, 2, 3, 4, 5, and 6.
Yeah, I was just posted in the chat. I'm actually taking a course, AI agent course.
Yep.
So I think it's consciousness.
Consciousness. Yeah. All right. With that said, we'll move on. And so today, once again, that part 3 is transfer learning and pre-trained models. And that will be the ResNet. We're looking at NLP, natural language processing, and transformers and GANs. And then there's a video I'm going to put for deploying PyTorch models, so you can actually watch that too as well. Here's the actual site with all the code. All of this code, every single line was prompt engineered. Okay, so let me go ahead and put this in here, and you can actually go here to this site. I'll go ahead and bring it up for you. It's all open to the public. So I have a lot of sites here, but anything all the way from PyTorch Playground, Intro to Tensors, Simple Noise MVP, Linear Regression, Logical Regression, FFN, CNN, RNN, ResNet, ResNet 2, Transformer 1, Transformer 2, GANs and deployment. All of this, every single line of code was prompt engineered. And you'll see some of it, the last 3 today. If you want to actually look at my Hugging Face, I have tons of code up there. You guys can go. Here's my Hugging Face right here, and you can just go through here. I think publicly I probably have about 85 spaces that I'm showing. So you can actually go there and look at all the code that I've written. So if you ever want to see what's being written and done in my space, you can go there. I've talked last time, you can go back and review the first video, a lot about different types of learning. And we had the ability, what I call pull learning versus push learning. And with the AI technology now, we can actually have learning on demand. We can get out there and just try to figure out something. And if you take a look at the course that I have out there, the whole outline was something I said, explain to me, give me a course that could be hands-on with Python that I can learn, and give me 10 hands-on projects. And that's what it did. And what this is a result of the course itself that was prompt engineered. But there's also push learning, and this is what we traditionally do. We set a bunch of students in a class, and we teach them. We push knowledge on them, and it's really, really inefficient. So given that we've done all this work with pulling knowledge, that we've been like asking it, hey, build a GAN, build this, do that, build this, explain that. And we've been doing that in the whole process. It's time you could take a break now and actually go through the PyTorch YouTube series. So PyTorch has a wonderful YouTube series out there. It's time to push some knowledge, but now that you spend all this time pulling, you have a place to hang your hat, and you're just going to soak it up. So basically, there's an intro to PyTorch, PyTorch tensors, AutoGrad, models in PyTorch, TensorBoard, PyTorch training, CAPTM, and finally deployment. First thing we want to build is a ResNet, basically for solving, and the thing that ResNet did for us, it solved the vanishing gradient problem. And so what that is, and we've already done CNN, convolutional neural networks. And what we want to do is be able to stack layers. The problem with stacking layers is that the gradient that adjusts the weights disappears. So what they decided to do with the gradient with the ResNet is pretty much feed the input further down the layers. And then with this, they were actually able to stack 152 layers. So let's see if we can actually build a ResNet. So the first prompt is going to be use a pre-trained model like ResNet from the PyTorch library for a custom image classification task, fine-tune the model on a data set. And the second prompt will be add a Streamlit interface. So you guys familiar what Streamlit is? But Streamlit, you can put right on top of your your Python system. What's amazing here is what you're seeing me do is build a minimal viable product. I start by building the first piece, and then I add the Streamlit interface on top of it. So many times when I'm building, I'm thinking of the most minimum thing I can build, and I'm starting to add or sculpt it. And so if you go right into the chat system, I'm gonna bring up chat GPT 4.0, excuse me, and I'm gonna prompt this for you guys. And Joe, I think you've been with me from the very beginning, so you've watched me prompt all this stuff. I don't know if you're getting
I'm your
tired.
biggest fan, Michael.
Oh, thank you, Joe. I appreciate it.
Well, you
So
may not
this-
like that if you remember the movie Misery, right?
So, I mean, I think someone mentioned a lot of people don't realize how advanced this stuff is becoming, and it's just pretty amazing. But if you do just stick that prompt in there, I'm going to show you something amazing about prompts today. We haven't got there, and it will go ahead, and I'm going to put ResNet. That's what I'm going to build, and just run it. It's going to go ahead and build that out for me. And it's going to choose it what for me. It's going to choose a model to train. There's your torch. There's your setup. There's
Hey,
your
Michael,
yeah.
and what do you use? Well, you're on Mac, right? So you're using the native tools in there to run this code, right?
I am
Or no,
not.
you're
I
using
am
Hugging
not.
Face.
I am taking it right to Hugging Face.
Okay.
It's going right to Hugging Face. Absolutely.
Are you going to show us that process?
Yeah, I will.
Cool. Thank you.
Sure. Now, once you've got that, then you want to put your Streamlit interface on top of it. Right. So I'm going to add my Streamlit interface. And then, Joe, I will show you the whole Hugging Face right after I do this. Okay.
Awesome.
So let's put the second prompt in there. Thanks, guys. All right. And let's run that. And what's it going to do? It's going to put a Streamlit interface on top of it. And you'll see there your Streamlit as ST on top of it. It's going to, I was going to start putting your transform layers in. All right, cool. Great. All right. So once you get your code, right, Joe, what you want to do is you want to copy that code.
Right.
And I'm going to take you to Hugging Face and I'm going to show you the whole process. So when you go to Hugging Face, this is my Hugging Face. Now Hugging Face is free, but you guys can, I pay $10 a month for it. But and I get some other features. But here's my PyTorch right here. And what's really nice about this PyTorch setup is that you have this top level app. And this whole thing was prompt engineered. So this whole course, like I said, everything here has been prompt engineered. And then if you open up files, you can actually see how it was written. And there's a folder called Pages. You see that?
Mm-hmm.
And in that pages are all your applications. And what's nice about this, they're all separate. So you can see here's my CNN, my convolutional neural network. And then here's my today we're looking at the ResNex, and this is what I wrote last. So this is what we just prompt engineered. So what you would do is that you would go in here and create that page and just paste it in. So here's your Streamlit, and you can see it's very similar to what we just wrote. Right?
Okay.
And that's it. That's all there is to it. And because they're all separate, because the nice thing about the pages, whatever you put in the pages, it doesn't have to, it's completely a completely different type of application. So it's perfect for this type of work because what you're doing is you're sculpting. So you may come in here and we'll go back to the application. Come in here and you may go, okay, I'm sculpting something. Now let's change it a little bit. Let's change it a little bit. Let's change it a little bit. And so you're just building up applications. You may not want to delete applications or rewrite them because you may like something you previously did. So lots of times I'll just keep sculpting and then I'll go and reevaluate what I have. So that's really all there is to it. And all you need is a Hugging Face account and start prompting and just throw it in here. Now, if you get an error, what you do is you copy that error, put it into your chat system and say, fix. Okay. And we'll do this if we have time when we get to the GANs, we'll try it for the GANs. Okay. Because I did have an error on the GANs and I did fix it. So when we get to the GANs, we'll actually go through we'll actually put it in. We don't have a whole lot of time, so we'll see where we get. With that said, let's go and move on with this a little faster. And so that's how you prompt it. And let's go ahead and take a look at the application that was built from that. That's your or your ResNet. Excuse me, go there. Here's your ResNet right here. And so it took a small set of the CFAR10 data set. Now, one of the problems that you have is as these applications, these algorithms get more advanced, it takes longer and longer for it to run in Hugging Face, right? Because it's actually building the model on the fly in memory. So what you're going to do for the next course, that's why there's a need for to go on to Hugging Face and actually start working with models. And so the next course will all be about building and tuning models in Hugging Face. So this, you can tell as you go here and you hit, let's train this model, you can choose the learning rate, and you can choose the number of epochs, and you can choose the batch size. And as you hit that train, it's just going to train for a very long time actually to crank that one out. See, it's starting to build the epochs right now. And so the final result of that, I'll show you the final results and we're going to move on. Because I think I only chose like 5 epochs for this particular one. You'd want to do more, but you can see that the learning loss curve's going down, which is good. And the validation is going up, but you see it's starting to level off. So you're not getting the bang for the buck that you'd want for this one. I'll move on to the next one. That was ResNet. Let's move on to Transformer. So we had these recurrent neural networks and they were great. And people want to like to use them to like predict what's going to happen in time. Let's predict what the stock market and all these things. The problem with them as you tried to add more layers, they would forget. And so you needed to, in a sense, get them to remember, right? And so the recurrent neural net has a short reference window. That's the problem with it. So no matter how hard you worked on it, eventually by the time, if you had a lot of layers, by the time you got to the end, it would forget. So they came up with the idea of transformers. And transformers has the ability to actually go through, and as it writes a story, for example, it can actually go to every word throughout that story. So if you have an author that's going to write a book, right? And say you start writing the book and you forget what happened in the beginning and you're trying to write the end, you're not a very good author. And that's kind of what was happening with recurrent neural networks and with ResNet. But when you use the transformer model, it's going to look at and categorize not just the words, but where the words are. This is extremely important, okay? Keeping track, when we do translation, we learn translation in school, what do? We learn it word for word, right? This, car in, in Spanish or back and forth. But what these systems do, they don't just do direct translation. They also understand the context where the word is. And that's extremely important. So in this particular case, you see, could potentially, if you have an infinite amount of compute power, you have an infinite reference window to go back and reference every single word in the book as you're writing the book forward. So that's kind of the idea of transformers. And it all came from this very famous paper called Attention is All You Need. And it consists of a decoder and encoder architecture. And the big deal about it, and here's the big deal, is keeping track, giving you basically a matrix of how important words are in a sentence to what you're trying to do. So it doesn't just fix my spelling, it understands my word positioning. And here it comes. I'm going to prompt this, but I'm going to do 2 different prompts. You see my top prompt? You probably can read that really well. You see my bottom prompt? Can you read that? It's about half the size. And this bottom prompt is going to give me a better program than the top prompt. All right, so let's go and run this. I'll show it to you. So what we're going to do here, we're going to create an NLP transformer example using PyTorch that will run Hugging Face. Put a Streamlit interface on it that will take the appropriate inputs and outputs and include a matplotlib graph if necessary with the output. The code should be all together to make it easy to paste. So let's put that into ChatGPT and see what happens.
I think while you do that, right, there's one more problem with the RNN is the text has to be sequenced. For example, cat sat on the mat. If you flip it, right, it's a different meaning. So that's another problem with the RNN.
Absolutely. You got it. Absolutely. And that's why transformers are so important, because if you flip the sequence, it knows. It understands sequencing. And so this just cranked it out. And let me take a look at the code real quick. And this is pretty much similar to what I wrote earlier. So it works really well. We'll run the code here in a moment, but I want to run the other one. So we come along here and let's run the other one. How do you think I made that?
You kind of change the letter by something else, like a little bit gibberish, but or remove the letter. Looks like you removed some text transformer. So
It's
you
gonna
kind of
it's
made.
gonna run better than the other one. And the reason it's gonna run better than the other one, and the reason you can get away with this, is because it understands positions of words. You know what I'm saying? It's the word positioning piece that allows you to do this, along with, of course, spelling check, right? Spelling error. It knows how to fix spell. I mean, if you've been working with ChatGPT for any amount of time, if you spell something wrong, most of the time it doesn't care. It just fixes it for you. So what I did here with this particular prompt, the first thing I did is said remove all non-essential words. All right. The second thing I did, I said drop all vowels. Why will you think that why dropping all vowels might work? Because that's an abjad language. Have you ever heard of the abjad language? The earliest languages in the world were abjad language. They had no vowels. And so I like to put on this fulfilling the prophecy, because there's this old prophecy about as it was in the days of Noah when there was an abjad language. So it will be in the latter days. So it's kind of scary. But what I'm going to tell you is that AI will eventually develop its own language. We cannot understand that, we will not be able to understand. One is that, and one that is more efficient than we can create ourselves, and they will talk to other AIs using this language. That's my prediction.
Actually, a fun story. I think in 60s, one scientist he came up with some one language so that like he wanted to
Yeah.
some kind of extreme. He came up
Yeah.
with some language and
Yeah.
like 4,000 words or something, like common words between Spanish, French, and
Yeah.
he
Yeah.
invented language and so that
Yeah.
you can have extreme in 1961 computer scientist, it seems the AI as part of AI.
Yeah.
So that's what I learned recently. Like, there's a book also about it. He came up
Yeah.
with some
Yeah.
language so
Yeah.
that
A lot of people have talked about something called Erdonic, an Erdonic language, something like that. Yeah, absolutely. I've actually read similar books as well. Let's put this in the prompt and see what we get. There you go. It's gonna do it. Just nuts. Just nuts. So I would try to even compress this more, and maybe write another prompt and say, don't let any of the words be more than 4 letters, and see if I can get away with that. So I actually did this. And if you go back to the application and you take a look at the first one, that's the transformer prompt 1. And so I could say and what it's going to do is sentiment analysis. So my wife loved the movie. So this is the first one. Let's analyze it. And no, this is going to run pretty fast because you're running on Hugging Face now. So you just got a model that you're running. So we're not building the model in memory as we have with the other ones previously. And so that really is not very informational. So let's look at the second one that was what was written by the prompt that was googly gop. Let's see what that gives us. Okay. Say my wife enjoyed the movie. Let's classify. I'm crossing my fingers. Hopefully the demo gods. Oh, now it's giving it stars. Oh, I got a little more information here. Got a 4-star.
But try a little bit, more not so direct. Let's say, I don't know, the movie is delightful, but something like more like not so straight up. Then that's more the fun.
Well, go ahead. Go ahead. The movie is
I don't know.
delightful.
The movie is delightful, but it was long, laborious. Something I'm giving you more negative connotation. But
Yeah, I've seen it where you start with the negative and end with the positive, and that
exactly. That's more the
so you put in there,
right?
even though the movie was too long, it was still very enjoyable.
Yeah, that's where the Netflix struggles, right? If somebody says excellent, sure, it there's no struggle there.
Or
But
I still enjoyed it, or something like that. Yeah.
yeah. So this is where actually it's called a more multi-label classification within the good or bad, and again, you again
Okay,
another
so I got
label.
this one in here. Let's see.
Yeah, let's give it a shot.
Let's see what the first one gives us.
So what's our expected output supposed to be of this, or do we know?
Well, yeah, well, you're seeing it here. All it's giving here is a positive and negative. It actually gave you a positive on this one, but it didn't give you a whole lot of information. The next one, the one that was written by the gobbledygook, is actually going to give you more information. Let's see what it gives you. So the 4 stars means it's positive, but you got some negative coming up here. See what I'm saying? So it's catching the fact that there was a little bit of negative there. You see what I'm saying? So the 4 stars means that's pretty positive, but you've got a little bit negative here over on the 3 side. Yeah. So you can see this is
There's a way to write it. I've seen this somewhere, and there's a way you can write it that sounds very negative, but actually is very positive, right?
Right.
And I remember seeing it on times because it can't understand the nuances
Exactly,
of,
right?
of the
Exactly.
human language, right?
I will have to
yeah.
say, and the point here is that the one that was written by the Godly group gave you more information than the one that was not.
Yeah.
So and so I thought that was very interesting. So yeah, I mean, welcome, Abject is here. So that
It
said,
also doesn't get sarcasm, I don't believe. So
well, I would have to test it out. So
yeah.
but that's beyond the scope of today. So we'll move on.
Oh yeah, sorry.
No, I appreciate your comments. Okay, the last one I'm talking about basically is GANs, and that's basically GANs just were really super, right? And the idea came from gaming. So if you ever did gaming, you know, and you work with a smart agent, they get smarter as you play the game, right? And so it's this artificial one against another. So basically, GANs took that idea. So GANs learned to generate new data with the same statistics as this training set. And there's a nice video here on it if you want to learn more. I'll put this in the chat. But basically, they're adversarial neural networks. They're fighting against each other, trying to predict what the other person is going to do, and they get smarter and smarter. So GANs consist of 2 networks playing an adversarial game against each other. The generator, there's 2. There's a generator and discriminator. The generator produces fake data and tries to trick the discriminator. The discriminator inspects the fake data and determines if it's real or fake. Generator and discriminators are randomly initialized in the beginning, and they are trained simultaneously. They're minimized. They basically it's you minimize loss, and you use something like a BCE loss metric. So I won't talk a whole lot about that. But if you're used to GANs or play with GANs, there's a site out there called "I'm Not a Real Person." Have you heard of that? Let me see if I can pull that up. They're GAN
Yeah,
generated.
there's a website actually. It'll show you people, but they're not real people.
Yeah,
It just
I'm
generate.
not a real
Yeah.
person. They are generated by GANs. Let me see if I can find it. And there you go. Let's see if it is. See if that site face generated. And these are all generated by GANs.
Yeah, these are all not real people, fictitious people.
For sure. Yep, that's an example of one. And I think you can just continue to refresh it. This is a different type one. There you go. Yeah, not real people. So this actually came out a while ago. This is not new stuff here, but being able to prompt this stuff is pretty new, like this. So this particular system, the GAN system I gave here pretty much was the famous MNIST database. And well, this kind of runs slow on my machine, but I'll go ahead and show it to you. But let's go ahead and prompt it. And all the prompt was create a simple GAN with a slider, and that lets you set the epoch. So let's do that real quick. So you go right into your prompt. Now, I want to say that I'm getting away with it a little bit because I'm using something called queuing. Are you familiar with prompting and queuing? What queuing is as soon as I use certain words, it cues in to the fact that it kind of these systems are trying to do is predict who you are and what you're trying to do. So if I say create a simple GAN with a slider, as soon as I say that, it knows my intellectual level. I mean, not every pilot would be asking for a GAN, right? So it probably has determined that I'm a Python programmer. And with a simple slider that lets you set the epoch. So as soon as you do that, pretty amazing. It's going to crank it out. Right, this stuff is pretty amazing. I mean, you're just speaking code into existence, right? So what we're going to do, I promised you, Joe, we'll see if this runs, okay? So we'll set, hopefully we'll get an error, and we'll try to fix that error. So we're right here in real live demo space, so we'll see how this goes. And there's your BCE loss. We talked about that, so that's being set there. All right, so if it doesn't work, then we can feed the results back and see if it will fix it. If it doesn't fix it, I'm going to be pretty sad. You guys will never believe another thing I say. So let's go ahead and build this out. Okay, Joe, what do you think?
Let's do it.
Let's do it. So we're going to go to Hugging Face, and we're going to go to PyTorch. And now you can watch me do this. So if I'm going to go into the file structure, and I'm going to go to pages. And the last page I did was 23. Notice I've been putting 2 between each. That's so I can insert something if I need to. So let's go ahead and add a file. And we'll call this 26. I think the other one's 25. Hopefully GANs. PY. That's for Python. So it needs to be that. And go ahead and paste that in. Now notice at the top that I have all these imports that I need. So I've already got those imports in the requirements file. So let me go ahead and hit main here, and that's going to compile it. But let me show you the requirements file. So you also need to have a requirements file that has all of those inputs. You see that? So everything I've been doing as I built this up, I've been adding more and more and more of these programs, Torch, Torch Vision, Matplotlib, Streamlit, NumPy, Pillow, TouchText. Each time I build something in, it doesn't run. It might ask for this, and I just put it in the requirements file. Okay. So if you run something and it says it's missing a resource, you want to put it in your requirements file.txt. With that said, I don't need to do anything to this, and it's already compiled. So I'll go to app, and let's see, there's my GANs down here. So I didn't number it correctly, but it's here. And let me go ahead and see if it runs. Cross your finger. I'm kind of hoping it doesn't run the first time. Okay, let's see what happens. You know what? Let me bring the GANs down because this will take forever to run. Let's just give it 2 epochs, okay? We'll give it 2 epochs. And then it's the output that I might get an error on if it actually got it right. And this will
Yeah,
take
so this is kind of like what I do in Stable Diffusion when I train a model in Stable Diffusion, right? Okay.
Yeah. Yeah. Oh yeah. Oh yeah. This is you're actually doing some.
That's for images, right? Stable diffusion for images, right?
Yep. Stable diffusions for images. This may give a few issues. Let me go ahead and as this is, we're going to move on with the presentation. We'll come back to this in a moment. We'll just let it run in the background as we kind of wrap up here. We got about 14 or 15 minutes, so we got a lot of time. But just a few things. What I did here is there's a wonderful YouTube set that you guys need to look at. And so once you've done through this, you've gone through this exercise, you've built all these out, and you've done all this poll exercise, then you want to go look at a nice, series on YouTube that you can watch from PyTorch. So the authors of PyTorch actually made this, and it's really good. I mean, the videos are just outstanding. And the last one is on deployment. So if you actually go to my PyTorch, I mean, with AI, just a week is like a year, right? Because everything's
that's my complaint too. The libraries documentation out of date a week later, it doesn't work. So
and that's one of the complaints about people who try to use Udemy. I love Udemy as a training source. The problem with Udemy is that by the time you get a course out there, it's changed,
6
especially
months.
with this new technology. So what I do after you've done your Udemy courses and after you've done all the YouTube you can, then what you're trying to do is you're competing. That's why I compete in so many hackathons, is because that's the newest technology. They're always on the newest thing. If you guys are ever interested in competing in hackathons, a nice one that's doing a lot of generative AI is LabLab AI. I'm going to put this.
Is it like in person or is it like is like Kaggle or not like Kaggle, but you
in a way it's like Kaggle, but what you do here is it's Kaggle for generative AI. So you're not really building models, you're using models to build like websites and stuff like that. And so if you look at this particular site and you scroll down, you can see Agile Loop Hackathon, Codestral Hackathon, Llama 3 Hackathon, Build Your Startup Hackathon, Hello GPT 4.0 Hackathon. These are all kind of the newest technologies that are rolling out, and so they have hackathons on this. So if you want, like I said, once you've done all the Udemy and you can and all the YouTubes you can, if you want to keep learning the newest thing, you're going to be competing in hackathons. I'm going to go ahead and put this also in the chat for you guys if you ever decide you want to do one.
So that's how you do. That's how you keep up to.
That's how I keep up. I'm pretty much participating in a hackathon every week. Okay, so it's still cranking out. So it's going to take a long time to train this GAN, but it seems to be working. Let's take a look at the logs and see if it's cranking out okay. Yep, doesn't seem to have an error here, but you could get an error on the output. And if you do, you want to feed that error back. But there's a lot involved in this particular one. Well, with that said, I can show you the results of the one I did run. So that's the only problem I found with these particular exercises. As you got more advanced in the technology and has had to build more, they really slowed down. So you're going to want to run these on a higher GPU, but if you do that, you're going to pay for it. So I'm trying to keep my expenses down. If you've done a lot of AI, you know it can be expensive, and you're always incurring costs. So I try to keep it down.
I use a Google Colab and constantly, especially if you're training these images, right?
Right.
You get 100 units for, I think, I don't know, $15, whatever,
Right.
$20. That $50 goes like ice cream whenever you're training.
Right.
That's another complaint. You just forget to stop and go for a coffee and come back.
Yeah.
Ice cream melting. That's it.
And the thing about what I do, I'm like an application builder. So I'll take a notebook like that, a Google Colab notebook, and I'll take that into like a chat interface, and I'll say put a Streamlit interface on it and build an application for me. And another thing I'll do is when I copy it, I'll copy the comments as well, because those comments act like queuing. And I've had instances where I've taken a Google notebook, like a notebook, a Jupyter notebook, and I've turned it into a Streamlit app, and it actually was better than the Jupyter Notebook because it took the comments and understood more of what it wanted to build.
Right.
All right. With that said, let's see what we got here as we move to the end here. And this is one of my shortest lectures on this, but I want to wrap it up. We went through the GANs, and here was an example where I ran basically just 6 epochs, and it was trying to, I think it was either the number 3 or 9. So I was trying to train to get the number 3 or 9. And I didn't run enough. So if I'd run maybe 100 epochs, it would be showing a lot better than it did now, but it worked. And so I was happy about that. And then the last piece was the deployment video. So you guys can watch that, come up to speed on deployment in PyTorch. Now, the next series I'm going to be working on is Hugging Face and tuning models. So that's going to be a little more intensive than this was, but it's going to be more useful because you can actually, and you can use PyTorch with Hugging Face as well. So that kind of wraps everything up. I mean, it was nice to do this 3 series. We've got about 10 minutes left. I'm open to any type of discussion.